I want to look at the activity series with you in this set of slides to show you how to work single replacement reactions. So let's get started. You know that from doing labs, some single replacement reactions will occur quickly while others don't occur at all. And the reason that is because some elements are more active than others. Take for example gold and silver. You know, we make a lot of our jewelry out of those metals, so it's a good thing that they're not very reactive. But then some elements like sodium are very reactive. They're so reactive, in fact, that you have to store them in oil, because if they come into contact with water or water vapor in the air, they'll ignite and start a reaction that's pretty violent. Now, the activity series of the metals is in your reference tables, and it is kind of a list or an order of the reactivity of metals and of these elements. So the most active elements are going to be at the top of the list, while the less reactive elements are down at the bottom. And the way the activity series works is that any element can replace any element that's lower than it is in the activity series. And the only time we're going to use this series is for single replacement reactions. So don't forget that. I don't want you using it for every reaction. Alright, so let me show you how it works with this example. The first one is aluminum plus zinc chloride. Now, the aluminum is the single element here, and zinc chloride is a compound, so you're going to recognize that as a single replacement reaction. For this reaction to occur, the aluminum has to be able to replace the zinc in zinc chloride. So the aluminum is going to need to be higher in the list. Now, if you look at the activity series list in your reference tables, you'll see that aluminum is higher than zinc. So what that means is that aluminum breaks the bond between zinc and chlorine and forms aluminum chloride plus zinc. And I've written those products on the right side of the arrow for you. Now look at the second example. I'm going to let you try. Copper plus sodium chloride is the single replacement reaction. Can copper replace the sodium? Now remember, to do this, copper must be higher in the list than sodium. So look at the list and see what you think. When you check the list, you'll see that copper is actually below sodium in the list. So this reaction will not occur. All you need to do on the right side of the yields arrow here is to write no reaction. Alright, in your note-taking guide, you have these practice problems. So I want you to pause the video and see if you can work these out. Remember that when you write the products for a single replacement reaction, you have to do charges and crisscrosses for that new compound that forms on the product side of the equation. So pause now, try these, and start the video again, and I'll show you the answers. So here are the answers. The first reaction in fact does happen. Chromium can replace lead, and I did charges and crisscrosses to get chromium nitrate and lead as my products. The next two reactions do not happen. Platinum cannot replace calcium in the second one, and in the third one manganese cannot replace magnesium, so I just put no reaction. The fourth reaction actually does happen. Calcium can replace iron, and if you do charges and crisscross, you get CaBr2, calcium bromide, plus the new element iron. So I hope that helps. There is one extra practice problem on your note-taking guide for the nonmetals. You have that list in your reference packet as well. It works the same way. See if you can figure that out, because for the nonmetals, remember the most reactive nonmetals are at the top of the periodic table, especially in group 17. So I will see you tomorrow and we'll work some more of these.